Okay, so in the question given, draw a cycloid of a circle of diameter 50 mm for one revolution. Also draw a tangent and normal to the curve at a point 35 mm above the baseline. So first in the question we understand what is cycloid. So cycloid means it is nothing but a curve generated by a point on the circumference of a circle that rolls along a straight line. You can see in this diagram clearly. So there is a circle on the circumference of a circle there is a point P. So as it is roll along this straight line, what happens? It is forming an curve here. Okay, forming an curve. So this curve we call it that is a cycloid. Okay, the curve generated by a point on the circumference of a circle that rolls along the straight line. Okay, you can see that point P, as this circle rolls along this straight line, it is forming a curve here. So this is what we called as a cycloid. So in this question we have to construct a cycloid of a circle of diameter 50 mm for one revolution. So for one complete revolution we have to draw the cycloid. So that is the first thing we will be constructing, that is constructing a cycloid of a diameter 50. Okay, that is first we draw a circle, then we divide into 12 equal parts, then we draw a straight line, then again we divide that straight line again into 12 equal parts. Okay, then the procedure starts. Okay. Okay, now we have to find out the circumference of this circle. Okay, we know the formula, that is 2 pi r. Okay, the diameter given in this problem it is 50 mm. The radius will be 25. So it will be total 157 mm. So if we convert that into centimeter, it is 15.7 centimeter. That means first I'll be drawing a circle of 50, dividing into 12 equal parts. Okay, and then drawing a straight line which is of length 15.7 centimeter. Okay. Okay, now you can see I'm measuring a here radius of 25. Okay, 25 mm, nothing but 2.5 centimeter from the scale, and I'm going to draw one circle here. Okay, here I'll draw. Okay, okay, now I have to divide this circle into 12 equal parts. Okay. So we know it is, if we are dividing a circle into 12 equal parts, it is 360 divided by 12, that is 30-degree inclination we have to take. Okay, I'll use this protractor. Okay, mark for angle 30, 60, 90, 120, 150. So what I'll do is, using the scale, can draw the lines for an angle of 30-degree difference. Okay. Now I can extend these lines. Okay. Okay, so now you can see this is completely divided into 12 equal parts. I can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now I'll be drawing from this point. Okay, a length of how much it is? The length of 15.7. Okay, 15.7 centimeter. So can keep the scale here and mark a point of 15.7. okay, then draw a straight line. Okay, so now we have to divide this straight line into 12 equal parts. So for that, what I'll do, just draw one line here. Okay, and I'll take compass. Okay, take compass, and I'm going to measure any length. Okay, any length you can measure and cut the arc, because we have to divide this line into 12 equal parts. Any length you can measure and cut 12 parts. 2, 3, 4, 5, 6, 7, okay, 8, 9, 10, 11, 12. Okay, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, what we have to do is we have to join this point with this point. Okay, now parallelly we have to draw the same lines so that it will be divided. So that's why I'm using the ruler scale. Okay, now it is divided into 12 equal parts. Okay, so now I can write it as 1, 2 dash, 3 dash, 4 dash, okay, 5, 6, 7, 8, 10. Sorry, so we can write this is as 1, 2, 3, 4, 5, 6, 7, 8. This is 9, this is 10, 11, 12. Okay, so now we'll draw parallel lines here. Okay, parallel lines. Okay, so center point, you can see as this circle rolls over any reference point, the center point remains the same. Okay, so for that, okay, now here you can see 1 and 11, we get it on the same point. 10 and 2, same way. Okay. 8 and 4, 7 and 5, and then finally we have this 6. So now after this we have to mark exactly the perpendicular points so that we can mark a C1 C2 like that. Okay, so for that I'm using different color sketch. Okay, so parallelly, so this from point C1 okay 2 3 4 5 6 8 9 10 11. Okay, so that we can give this as C1 C2 C3 C4 C5 C6 C7 C8 C9 C10 C11 C12. So whenever the circle rotates here, the center points will be remaining same. Okay, so that's what we have written here. Okay, now here for pointing this, tracing out the point, we will be using different color sketch here. I'll give this as P1. Okay, P1. So what we have to do here it is, so we have to measure this radius length. Okay, radius length we have to measure. Okay, and from this point C1, okay, C1 we have to cut the arc on this, that is our C1, and then we have this P2, and then we have this C3 here, and then we have this point C4, and then we have this point C5, then we have this point C6, and then we have this point C7, and then we have this point C8. Okay, and then C9 will be here. Okay, C10 we have exactly here, and then C11 we got it here, and then finally we have the C12. Okay, so now we can mark these points. So where we are getting this is P2, P3, P4, P5, P6, P7, P8, P9, okay, P10, P11, and sorry, this is P10, P1, P2, P3, P6, P7, P8, P9. Okay, we have done with the naming now. Okay, this is we have to neglect from here. Okay, P12. Okay, you have to join P12, P2, and P22. We have this P3, P32, P4, P42, P5, P52, P6, and then P6 to P7, P7 to P8, P8 to P9, P9 to P10. Okay, here P10, P11, and P11 to P12. So now we can dark this one. Okay, different color. So this is what the cycloid is completed. Now we have to draw the tangent and the normal. Okay, tangent and the normal. So in the question, given, also draw the tangent and normal to the curve at a point of 35 mm above the baseline. So you can see in this question, so we have to construct a 35 mm line. So this is our baseline. Okay, this is our baseline. So 35 mm we have to consider. So from this base, so 35 mm exactly where it is touching the arc point, I'll mark. Okay, that point as M, I'll mark. Okay, this point. So I'll draw one straight line here. So from this point, so I need to measure the radius length, this length of 25. So we have measured, then we have to cut an arc. Okay, we have to measure the radius length. Okay, which is already measured. So from this point of M, okay, you have to cut on this center line. So we mark that as X here. Okay, now draw a straight line. Okay, parallel to this, draw. Okay, this is your end point. Okay, now we have to join, okay, this N and M with the straight line. Okay, now exactly perpendicular to this, okay, that is what our tangent. Okay, this is your normal. Okay, you can give this n1. So now exactly perpendicular to this line, if you draw a line, that is what your tangent. Okay, so mark for 90 degree. Okay, okay, that is your tangent. I'll write t dash. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching the video.